So what are solids? Solids have a definite shape. Okay, so they have definite shape. So definite shape means they always have a particular, they always close to all the particles inside the solids are very close to each other. Okay, you cannot compress them further. Okay, so they are already compressed shape. Okay, and they have very strong intermolecular forces. This is a very important vocabulary here called intermolecular forces, called the IMF. Okay, so it's called intermolecular force, IMF. So because the force between each and every molecules inside a solid structure is very strong, they are very close to each other. Okay, and since they are very close to each other, they can only vibrate in their own motion. So they can vibrate only in their space that is available to them. So solids are having a very definite shape and you and volume. Okay, they have shape and volume, and you cannot compress them. Okay, they are close to each other, and they have very strong intermolecular forces, and they can only vibrate. Okay, so they have only vibrational motion. So this is very important compared to solids. But when you come to liquids, you see, take a different color. When you come to liquids, they can always take a shape of a container. So that we know, very simple thing, right? It can take a shape of a container, and it will have a fixed volume, right? So wherever the volume it has fixed volume, but they move a little bit far away as easily. Okay, so they have some spaces available. They can move far away. Each molecule can move from little bit far away from each other. So they have two types of motion here. One, here in solid, you have only vibration, but here you have both vibration and also translation motion. So translational motion is also available. So basically, each molecule can vibrate. At the same time, they can also move in different directions easily, slightly movable. So that is called liquids. So they can, each and every particle can move now. Now the next is the gases. The gases are little more random, right? So the random is random. This is called entropy. We call in chemistry, from solid to liquid, liquid to gas, the entropy increases. So how the entropy is increasing? The shape of the container, okay, it is going to hold on to the shape and volume of the container, right? So this is very similar to the liquid, but it's going to fill the entire container. It is not going to stay at the certain level. It's going to fill the entire space. But the molecules can fly far away from each other. So that is the reason it's going to fill the entire container. But the beauty about the gases is you can compress them into a small space also, right? So you can compress them into small space also, or you can let it fly into a big space also. So it is compressible. But the other solids and liquids, it's not compressible, but the gases are compressible. But they have a constant random motion. But constant random motion means they will be moving like in a straight line all the time, like zombies. They just move like straight line all the time and try to go and hit on the wall. And then they just come back in straight line and then goes and hits on the another wall. That's all. So they have now three types of motions now. One is each and every molecule can vibrate on its own. It can vibrate on its own, and it can move now, right? And it can also rotate on its own. So you have vibrational, translational, and rotational. So if you look at the difference between the solid, liquids, and gases, the intermolecular forces changes between these three phases. And when it changes, the beauty is about the motions are different from one. They have one motion, one freedom. It has two types of freedom now. It has now three types of freedom. So that is why the entropy that we call the randomness, the entropy or the randomness is increasing from left to right.